I have this dumb series where I write stuff in assembly. Huh? But assembly? Isn't that for old people? Well, not anymore. Meet Construct. It's basically assembly++, but I didn't name it that because that is a stupid name. It's similar to, and also transpiles to NASM, the assembler for Linux, but with some very nice abstractions without sacrificing speed or control. Which is of course what it's all about.
Writing small programs in NASM is actually a very good time and lets you use all sorts of tricks you wouldn't be able to use in a higher level language. Because in assembly you can freely use the CPU registers without having to do whatever the hell this is. But despite this, it has a lot of little things that make it a very frustrating experience. Like, let's say you want to call a function. You have to manually move every argument in the CPU register before calling it. But then you get to writing the function itself and it gets even worse, because there are no actual arguments. You have to either remember or comment in what register holds what parameter and then try not to confuse RDI with RSI, which takes up like 90% of your brain power while coding. So how did I attempt to fix these issues? Here's a function that makes a string all lowercase. It checks if the current character is not a null terminator first, then if it's in the uppercase range. If so, it subtracts 32, which turns the character into its lowercase equivalent. I gave functions a pretty average syntax, except you still have to call them with the call keyword. There's just so much text in assembly code that doing it C-style didn't seem like a great idea to me. Now, to really avoid having to remember in what context which registers mean what, I implemented scoped macros that are only valid in their respective scope. You can macro them to just about anything, as long as it doesn't have any white spaces. Then there's if statements. They use pretty unique syntax for the comparison operators. They're derived from the instruction names for the conditional jumps. There are currently no and, or not operators. Now, I wasn't sure about implementing while loops, as I feel like one of the strong points of writing in pure assembly is the creativity you can apply to the program's control flow. But I figured in most cases a simple while loop is all you need, so I might as well. And there we go. Besides some small stuff, that's what makes up the construct language. So let's get around to actually compiling, or more so transpiling, this program to NASM. We read the file passed into the compiler, then parse it into a list of tokens that look like this. It has a token type, an indentation, because this language is indent sensitive, a bunch of pointers to the different structs for the possible types it could be, and a list of child tokens for ifs, whiles, and functions, which is assigned in the next step, the delinearized tokens function. What this does is just recognize what tokens belong to a certain if, while, or function, and adds that to its child tokens. It works by using a stack where it keeps pushing the token on the stack that changes the indentation, adds all the tokens on that new indentation, then pops it off once the indentation goes back down. And now it's time for the magic. The apply functions that convert all the construct code into NASM code. The construct tokens still remain, but they're just ignored in the last step of the program. Let's start with applying the functions. First, it adds a tag for the code to jump to when calling the function. It then loops over all the arguments and transforms them into construct macros, which get applied later. Then it adds a return, because otherwise everything will just flow into each other. Then come the if statements. Here, like with the functions, it adds a tag, but at the end of the if statement. It then adds a compare instruction that compares the two values from the condition. After that, it can jump to the end or continue to the body of the if, depending on the result of the comparison. Now, since we want to jump to the end if the condition is not met, we have to inverse the comparison first. Now we can slap a j character in front of it, and that will make it jump to the end if the condition is not met. While loops are pretty much identical to if statements, except they have an additional tag at the start and a jump to it at the end, so it loops as long as the condition holds. Function calls are very simple as well. It just loops over the arguments and moves them into their respective registers, then calls the specified function with the NASM call instruction. Then lastly, the macros are applied, and the tokens are linearized, and converted back into a string. In this process, all construct tokens are ignored. It's then written to a file for us to assemble and link. So let's do exactly that. First, we run construct to transpile our program into NASM code. Let's do L64 format, since we wrote it in 64-bit. Then we assemble it into an object file with NASM. Lastly, we link it with the C standard library, since we do use printf in our code. And tada! Hello World in its peak form, lowercase. So that's about it. I'll put a link in the description to the GitHub and maybe a Discord for it in case anyone ends up using it and has any questions or ideas or whatever. I do realize that the use of assembly nowadays is mostly just writing very small optimized programs, so most abstractions aren't really welcome. But I think even if you're not going to use the while loops or if statements, the rest of the features are still very convenient. Anyway, that's all. Thanks for watching, and I will see you next time.